Hello and welcome back to the channel. In this video, we're going to be learning about wrapper classes in Java. Now, we already know what primitive data types are, and we use them quite a lot in programming. Primitive data types include data types like int, float, double, boolean. Whenever you're creating a variable, you're most likely going to use a primitive data type to declare that variable. Primitive data types are simple to use. They're inbuilt into the Java programming language. When using a class or an object in your program, it's a bit more harder to use compared to primitive data types. If I want to create a variable that uses a primitive data type, I can just declare that variable. So maybe something like int a, and I can give it any value I want, which is of that primitive data type. However, using a class is a bit harder. If I want to use any variables or any methods of the class, I have to first create the object of the class. For example, if I want to take an input using the scanner class, you can see that it's much more complicated to do so compared to just using a primitive data types. However, our class does have a few more advantages. Besides using just variables, you can also use methods with the class. We have multiple methods we can use to take inputs in different ways. I can use the nextIn method to take an integer input. I can use the next double method to take a double input. I can use the next line method to take the next sentence as an input. With our primitive data types can't do this. I can only use them to declare variables. Another good example is when you're using the math class. Because we're using the math class as a class, I can use multiple methods in different ways to perform operations on simple variables. We don't have the same advantage with our primitive data types. To overcome this, we create what's called wrapper classes. To overcome this, Java provides for wrapper classes. Basically, every primitive data type in Java has a corresponding class. If you look at these primitive data types, the corresponding class of the primitive data type short has the same name, but the S is now capital. So you're going to have this as the name of your class. The int data type also has a corresponding class, and the name of this class is integer. The float data type also has a corresponding class. We call it float. And the double data type, it's going to be double, and the boolean data type is just going to be boolean. You notice that there's a common pattern. Every corresponding class has the same name as the primitive data type, but the first letter is going to be in uppercase. If you remember the conventions with class names, we know that the regular convention is to make sure that the first letter of your class name is a capital letter. Now, these classes have multiple methods that we can use so that we can do more with primitive data types than just using them to declare variables. Since these classes basically wrap our primitive data types, we call them wrapper classes. Even though they're called wrapper classes, they're just any regular class. They contain variables and they contain methods. And if you want to use them, you'll have to create an object of that class. Creating an object of the wrapper class uses the same format that we use with other classes. For example, let's create an object of the integer class. To do this, we're going to first write the name of our class. So we're going to write integer. And then you're going to write the name of your object. I'm just going to call my object obj. After this, we add the assignment operator to assign the object to this object name obj. And then we're going to actually create the object. So we're going to use the new keyword to create a new object of the integer class. Then I'm going to add these brackets. And inside the brackets, I can add whatever int value I want to assign to my object obj. So let's say I want to assign the value 55. Here, this integer class is wrapping this number or this value of the int data type. Now we have a way to assign a value to my object obj. But how do I print this value or obtain it from the object obj? If you remember how we use classes and objects, we know that instead of directly printing variables, we use getter methods to get the value. In this case, if I want to obtain this value, I can use a method called int value. This method is just going to return the int value that we've stored in this object obj. Let's now use this method to obtain this number 55. This method is just like any other method. We're going to first write the object name, in this case obj. We're going to use the dot operator, and then we're going to call the method. Since we're using an integer object, we're going to use the int value method. And in this case, the int value method is going to return the int value over here 55 that we've stored in this object obj. And the println statement is just going to print that value. It's just going to print 55. When I run this program, we are indeed going to get 55 as our output. And we can also create objects for other wrapper classes. For example, we can create an object of the boolean class. We'll call this object obj2 and we'll set this equal to new boolean, and in our brackets we're going to add the boolean value that we're using. For now, we'll set this to true. Basically, this object obj2 is going to be storing the primitive value true. Like the int value method, we also have a method for the Boolean class. So I can use the Boolean value method to get or obtain the primitive value stored in our Boolean object. Now let's use this Boolean value method to obtain the value that we've stored in our object obj2. Like I've shown before, I could add a println statement and call this method so that I print true, but I could also store that value in a different variable. I can create another variable of the Boolean data type. Let's call this variable a. I can set this variable equal to obj2 dot Boolean value. Here, when we call the Boolean value method, it's going to return the value that we've stored in our object obj2. Since we've stored true, it's going to return true. And finally, the variable a is going to store that value true. To show this, we can add a println statement to print the variable a. When I run this program, we're going to get our output as true. However, it gets really tiring to create an object every single time you want to wrap a value of a primitive data type into a corresponding wrapper class. It's also really tiring to always use a method to obtain the value. To make it simpler for us to use wrapper classes, Java provides us with autoboxing and unboxing. Autoboxing is when Java implicitly converts a value of a primitive data type to an object of a corresponding wrapper class. Here, instead of creating an object ourselves to wrap this primitive value in our wrapper class Boolean, we can use autobox. So I can remove this and I can directly put in true. What Java is going to do is that it's going to implicitly convert this true to an object of the Boolean wrapper class and store that object in its object name obj2. This is much faster, and it's quite similar to the way we declared and initialized variables of primitive data types. Unboxing is the exact opposite of autoboxing. When you're using unboxing, Java is going to implicitly convert the object of a wrapper class to the corresponding primitive data type. This basically means that you don't have to use these methods anymore. I can directly print the object obj2, or I can directly store this object obj2. Here, if I want to obtain this value true, I can directly use the name of my object obj2. We know that we can't directly print objects. However, Java is going to automatically convert this object into a primitive data type. It's going to convert the object of the Boolean class into a value of the Boolean data type. So here, printing obj2 is just going to print the value that's stored in obj2. When I run this program, we are going to get our output as true. The main advantage with autoboxing and unboxing is that the syntax that you're using now with wrapper classes is quite similar to the way we used primitive data types. So let's say I want to create an object of the integer class. Now it's a lot easier. I can just put in integer. I can write the name of my object, maybe something like a, and I can set this equal to whatever int value I want to store. So something like 25. Java is going to implicitly convert this 25 into the integer object of the integer class and store it under the object name a. To access this value, I don't need to use a getter method anymore. Java is going to implicitly give us the value whenever I use this object name a. So let's create an int variable, maybe something like b, and we'll set this equal to a. You notice that unlike before, I don't need to use the getter method int value. Implicitly, Java is going to convert this object a into the primitive value 25 and store that primitive int value in a variable b. When I add a println statement to print the variable b, it's just going to print 25. And when I run this program, that is exactly what we get. We get 25. Till now, all we've done with wrapper classes is store values and get values. We can also do this using primitive data types. Our wrapper classes become useful when you use the many methods that Java provides us with. Although there are multiple methods that you can use with every one of these wrapper classes, in this video I'm only going to be showing you the important methods. We're going to be looking at a few methods called parsing methods. All parsing methods do the same basic thing. They convert a string to a primitive data type. So for example, if I store the number 156 as a string, our parsing method is going to convert this string to the number 156 of the int data type. If I store the decimal number 91.125 as a string, our parsing method is going to convert this string to the double data type. We're mainly going to use them with integer values and decimal numbers. Depending on the data type I want to convert my string to, I have different parsing methods. In this case, since I want to convert my string to a value of the int data type, I'm going to be using a method called the parseInt method. Here, if I want to convert this string to a value of the double data type, I can use a method called the parse double method. But let's say I have a string with a large number of integer values and I want to convert this to an integer data type. Now I don't want to use an int data type because it might be too small. In that case, I can also use a method to convert this to the long data type. To convert the string to the long value, I can use a method called the parse long method. If the decimal number is a really small decimal, maybe something like 91.1, and I don't want to use a double, I can convert this string to the float data type as well. Only change I'm going to be making is writing float over here. I'm going to be using a different method now called the parse float method. It's important that you remember these 4 methods because they're really helpful. All our parsing methods have the same basic syntax. All our 4 methods are methods of wrapper classes. If you look at the parse int method, it's a method of the integer wrapper class. Our parse long method is a method of the long wrapper class. Our parse float method is a method of the float wrapper class. And the parse double method is a method of the double wrapper class. Although they are methods of these wrapper classes, they're still going to be returning a primitive value. Any parsing method is going to take the string value as the input and it's going to return a primitive value. Here, since we're using the parse int method, it's going to be returning a value of the int data type. If I'm using the parse long method, it's going to be returning a value of the long data type. If I'm using a parse float method, it's going to be returning a value of the float data type. And finally, if I'm using the parse double method, it's going to be returning a value of the double data type. Another important thing that you need to remember is that all our 4 parsing methods are static methods. A static method basically means that the method belongs to the class and not the object. This means that if I want to use my static methods, I don't need to create an object to use the methods. This makes it a bit easier to use our methods. If you remember, when you're using a static method, instead of using the object name, you're just going to use the class name. You're going to use the dot operator, and then you're going to call the method. So here, when I want to use the parse int method to convert a string to an int value, I don't need to create an object and use the parse int method. I can directly use the name of the class. In this case, integer, I can use the dot operator and then call the parse int method. Inside the brackets, I can add the string. So in this case, let's say I want to convert the string 177. Here, this parse int method is going to convert this string 177 into the int value 177. I can store that int value 177 returned by this parse int method in this variable a, and when I run this program, it's going to print the number 177, not the string 177. If I kept my int value in the string form, I can't perform operations like addition and subtraction. But since I've converted this to an int value, I can add or subtract or multiply or divide. In this case, let's just add the number 2. Since this is an int value, it's going to add 2 and we're going to get 179 as our output. When I run this program, we do get 179 as our output. The parse double method works the exact same way. I'm going to be calling the method using the class name because it's a static method. And once I call the method, in the brackets, I'm going to enter the string that I want to convert to a double. The parse double method is going to convert this to a double 3.1256 and it's going to store that double in this variable b. When I print b, it's going to print that double. So when I run this program, we are going to get the double 3.1256. An obvious question that you might have is, what if I'm trying to convert something like words or characters into primitive data types? Here I'm using the parse int method to convert this string hello to the int data type. Hello can't be converted to an integer. It's not possible to convert this to an int data type. So when I run this program, you notice that I'm actually going to get an exception or a runtime error. Even when I'm using something like the parse double method to convert this string or this word hello, since I can't convert this hello to a double, we're going to again get a runtime error or an exception. You also need to be careful when you're trying to convert a string which stores a double into something like an integer. We know that we can't implicitly convert something like a double into an integer using the parse int method. So here, when I run this program, we're again going to get an exception or a runtime error. However, if I try to convert an int value like 3 to a double, we don't get any error. When I run this program, I do get my output as 3.0. If you remember type conversion, an int value can be implicitly converted to a double because a double is larger than an int. Till now, we've looked at important wrapper classes like the integer wrapper class, the double wrapper class, or the boolean wrapper class. We also can create a wrapper class for the car data type. This wrapper class, called the character class, has many useful methods. In the next video, we're going to talk about all of these methods. Thank you for watching and have a great day.